It's recording now. I'm gonna share the screen. Can you guys see the screen now or not? Okay, I guess that you guys can actually see that. So, as you guys all know, today we're gonna learn about universe. I want to bring some new atmosphere and some new fresh air into our class because we already familiarize ourselves with biological terms, and it's kind of boring to just keep learning all of that for the rest of the class. So, for today's lesson, we're not gonna learn about biology, about human body, or cells, or plants, photosynthesis, stuff like that anymore. Today, we're learn about universe, which I think is a very fascinating concept. So yeah, without further ado, let's get into the lesson right away because we have a lot to learn today. So yeah, here's the content. Just go through it a little bit. So first, we're gonna learn about the introduction, which basically about the definition of universe, and then about the Big Bang theory. In case you don't know about that, it's just basically a hypothesis and a widely accepted hypothesis the beginning of our universe, which is kind of like really complicated, but I will try my best to simplify it as much as possible. And then we also gain some insights or expand our knowledge about stars, planets, and our solar system. And we also learn and look into like some fun facts or some knowledge about our solar systems, and we're gonna learn each planet in our solar system separately, which I think is absolutely fantastic. And then we also learn about some recent space discoveries. For example, some discoveries that NASA has proposed, or some recent discoveries that have expanded and captivated our mindset about Mars, stuff like that. And then some reflection too at the end of the lesson to recap every single knowledge we've just obtained so far. So first, let's jump right into the introduction of our universe. So what exactly is universe? Well, in simple one sentence, the universe is everything. It's literally everything. It includes all the space, the matter, energy, resources that space contains. It even includes time itself, and of course, it includes you. So that is a simple term of the universe. Wait a minute. My young brother had just come in and okay. Anyway, never mind. So that's that. We just basically need to know that the universe is literally everything, and every single energy laws and enforcements has been applied in our universe. It is basically every single thing that you observe and experience in real life situations. It can be the book, it can be people, human beings, plants. Basically, everything that is universe consists of everything. It's just something like that. So that's the universe. And what about the beginning of the universe, you may ask? Then we're gonna definitely have to look through the Big Bang Theory. Here it is. So, the Big Bang Theory is the debatable hypothesis about our existence approximately 14 billion years ago. Why did I define this as the debatable hypothesis? Because there are so many multiple theories and proposals about the beginning of the universe. We human beings cannot know exactly what happened at our universe 14 billion years ago. It is just a proposal and a widely accepted hypothesis. But in the past, human beings have come up with a lot of explanations and a lot of hypotheses and trying the best, making an attempt to explain the beginning of the universe. But the Big Bang Theory has been widely accepted among scientists and scholars at the beginning and the very existence of every life forms. So, also, in simple terms, the Big Bang Theory is essentially explained as the formation of our universe from a tiny singularity, which is basically a hot, dense, infinitely dense point which is really tiny. It's like million and million billions smaller than a single atoms. And then it gradually expanded and construct every single matter we experience today. So that's the explanation of the Big Bang Theory, and here's a little bit insights into that. Well, of course, I will definitely send you guys some videos to demonstrate my points, because if I'm just merely explaining it in my words, it can be a little bit abstract to visualize the process of the Big Bang Theory. So I did have a video for you guys to watch later on, but let me just explain a little bit first. So here it is. The universe began with just one hot, tiny, and dense singularity, which is really, really tiny. It's even smaller than the atomic point, whatever it is, but it's so tiny. We cannot see it with our naked eyes. However, approximately 14 billion years ago, we cannot know the exact or the specific time where the Big Bang Theory started, so it's just a merely hypothesis. 14 billion years ago, around that time, virtually everything changed. The point was suddenly expanding and stretching out, forming the first element called atom as the temperature cooled down. Well, it's actually not atom, but the very first chemical element that was formed from this whole process was helium, and then the hydrogen, and then gradually atom was formed. It's not actually atom, it's actually helium. I kind of misunderstood the concept a little bit. And then atoms formed together and the construction of stars and planets emerged. Because our literally everything was made up from atoms, right? And then stars, atoms made up and categorized into stars and planets and other life forms in our universe as we see right now. So then universe colliding with each other. It is really a mind-blowing fact, but maybe you don't know. Our universes are actually splitting away, and like in our universe there are multiple galaxies, right? And there's this proposal that the universes, or more specifically the galaxies, are expanding away from each other. So it's really caught me off guard because I've never anticipated such a mind-blowing fact emerged, but basically it's like that. And then the whole universe began, and then the stars formed, and then when the star's death emerged, it can lead to black holes, which would definitely look more, because black holes are truly fascinating, and black holes are hypothesized to form from the stars like the final stage, like its death, and then form asteroids and comets and the planets and stuff like that. So let's dig in these components of our universe, which is black holes and asteroids and comets and planets. But first, let's learn more the Big Bang Theory from this video. I will send you guys this link because I think this video clearly represented the information I'm trying to explain, because I'm not that good at explaining things. So please watch this video. I'm gonna send this in our chat box. Alright, here it is. So click on it and watch this video, because the narrator literally explained everything so good and so vividly. There are some problems with my YouTube, with the YouTube platform here, so I was literally unable to watch this video, but I'm trying my best to. Wait a minute.
The universe is everything, from the tiniest particles to the largest galaxies to the very existence of space, time, and life. But how did it all begin? The origin of the universe is the origin of everything. Multiple scientific theories, plus creation myths from around the world, have tried to explain its mysterious genesis. However, the most widely accepted explanation is the Big Bang Theory. The Big Bang Theory states that the universe began as a hot and infinitely dense point. Only a few millimeters wide, it was similar to a supercharged black hole. About 13.7 billion years ago, this tiny singularity violently exploded. And it is from this explosion, this bang, that all matter, energy, space, and time were created. What happened next were two major stages of the universe's evolution. Called the radiation and matter eras, they're defined by key events that helped shape the universe. First came the radiation era, named for the dominance of radiation right after the Big Bang. This era is made of smaller stages, called epochs, that occurred within the universe's first tens of thousands of years. The earliest is the Planck epoch. No matter existed in the universe at this time, only energy and the ancestor. This epoch ended when one of those forces, called strong or strong nuclear, broke away. Then, the inflationary epoch began, during which the universe rapidly expanded. Almost instantly, it grew from the size of an atom to the size of a grapefruit. The universe at this time was piping hot, and it churned with electrons, quarks, and other particles. Then came the electroweak epoch, when the last two forces, electromagnetic and weak, finally split off. During the next stage, the quark epoch, all of the universe's ingredients were present. However, the universe was still too hot and dense for subatomic particles to form. Then, in the hadron epoch, the universe cooled down enough for quarks to bind together and form protons and neutrons. In the lepton and nuclear epochs, the radiation era's last two stages, the protons and neutrons underwent a significant change. They fused and created nuclei. And in doing so, they created the first chemical element in the universe, helium. The universe's new ability to form elements, the building blocks of matter, cued the matter era. Much as the name suggests, the matter era is defined by the presence and predominance of matter in the universe. It features three epochs that span billions of years, the vast majority of the universe's lifespan, and includes the present day. The first was the clusters of atoms formed during the galactic epoch of stars then caused a tremendous ripple effect and helped shape the universe as we know it. Heat within the stars caused the conversion of helium and hydrogen into almost all the remaining elements in the universe. In turn, those elements became the building blocks for planets, moons, life, everything we see today. This ecosystem of everything was only possible because of the many stages in the universe's development. While countless questions about the origins of our universe remain, it's only a matter of time for some long-sought answers to emerge.
Have you guys finished watching the video yet? Okay, so some said no and some said that they had finished. So I will give you. Oh, Hangling, have you finished watching this yet, or do you need any more time?
Okay, I finished.
Alright, so as you can see that the Big Bang's formation is really complicated and there involved a lot of process, so you even may encounter some weird or unfamiliar
Your mic
terms
is
there.
not on.
Oh, sorry. Okay, so I am talking about that the Big Bang. Let me just try it again. So the Big Bang theory involves a lot of process and really complicated formation. So as you can see, you may encounter some unfamiliar terms and process in the video I've just sent you guys, but all you need to know is that the Big Bang Theory is the beginning of everything on the universe and is a very complicated, a very abstract concept that requires a lot of dedication and practice in order to comprehend every single terms there. So yeah, we have gone over the universe process. You can definitely learn more about this. I would send you guys some resources if you're interested in the universe formation, the Big Bang Theory. So let's move on to the next slide. Here, wait a minute. Alright, so now we'll learn more about the components inside the universe, which is stars and planets and black holes. So, okay, so I know that this looks so confusing because I don't know why. It's just the design, I guess, looks so freaking confusing. I don't know how to actually change and how to alter the outlines, but I will try my best to explain every single concept here. So first, we'll start off with a galaxy. Kick off the series of explaining the components with the galaxy concept. So, also in simple terms, the galaxy is a huge collection, means like the assemblance of gas, dust, and billions of stars and the solar systems, all held together by gravity. So, what exactly is gravity, right? Let me just do some quick research because I know how to explain it, but in Vietnamese, it means trọng lực. So basically, gravity is the force by which a planet or other body draws objects towards its center. For example, our Earth, right, our planet, orbiting around the sun because of the gravity of the sun is so strong that our Earth has been attracted to that force, and as a result, it's orbiting around the sun. So that's gravity. And galaxy is basically consists of every single components inside it, such as stars and black holes and planets, stuff like that. So that's a galaxy, which is a little bit smaller than the concept of universe. And then comes the stars. So one of the most notable example of star that you probably have already known is our sun, right? Because sun is also the star because it illuminates and it utilizes its internal resources in order to produce light and to warm our planet. So here's the explanation of star I've taken from National Geographic. So a star is any massive self-luminous. Self-luminous is it generalize or it generate its own planet, like its own resources and its own lights from themselves. So it just producing lights from itself, which is called self-luminous celestial body of gas that shines by radiation derived from its internal energy sources. So that's that. Basically stars. So if you're looking or observing the night sky, you may have noticed or pay attention to all the stars illuminating on the sky. Basically, our sky is dominated by the stars, right? You may see those illuminating and the glistening dots on the dark pitch night. So stars are really far away from our own planet. I think the nearest star, which is our sun, is billions of thousands of kilometers away from our own planet. So you may see that stars are those glistening and those glittering dots, but in reality, stars are much enormous and much lighter than that. So that's stars. And then move on, we have black hole, which I think is one of the most captivating concept in these whole components. I did have a video for you to watch about black holes, but let me just explain a little bit before diving into the video. So a black hole is a place in space where gravity pulls is so strong and so much that even light cannot get out. And that's the reason why black hole is called black hole, because there's no light to illuminate the black hole, and all we can see is a like black hole cannot be observed or detected by naked eyes. We have to use some specialized tools and equipment in order to detect and to help scientists observe black holes. So we normally would observe black holes from the outside consequences. What it means is that if you can detect any planets orbiting a undetectable or unidentifiable black holes, then it is presumably a black hole. We would have to pay attention to the outside activities in order to see whether or not to determine whether or not it is a black hole or not. It's maybe a little bit complicated, but here it is. Here's the video, because I think this video is literally so fascinating, I guess. But yeah, just send this again. So you definitely can learn a lot from this video about the black holes. But basically, black holes are unidentified, and we have to rely on the outside activities. Such, for example, if a planet orbiting around some sources that we cannot see, presumably it is a black hole that the stars or the planets are orbiting. So yeah, that's that. And just watch this video and I will explain further about black holes.
今日のスマートホームデバイスは互いにつながることができません。もどかしいことに、まさにそれぞれ
Black holes are among the most fascinating objects in our universe, and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return, beyond which we truly cannot see. When something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, Using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
Okay, so you guys did finish. I've just finished watching this video and I want to clarify some concepts here. Let me just rewind a little bit to this point. Okay, so first, we encounter the first type of black holes, which is stellar black holes. So, stellar black holes are formed after a star's death. So for example, if our sun is running out of resources and it is entering the final stage of its life, then it will gradually become a black hole, because whenever a star is dying, it will gradually expanding and decompressing into a black hole like this. So any star that holds the planet, I guess, can become a black hole, and more specifically a stellar black holes. And as you've watched this video, our universe alone contains millions of these types of black holes. But one of the most scarred and the most fascinating black holes I want to emphasize here is definitely the supermassive black holes, which scientists has theorized to have been existing at the center of every single galaxy, including our own. So supermassive black holes exist at our center of the galaxy, and actually this has a name. Okay, our massive black holes has a name, but I kind of forget about that actually. Here it is. Here's the picture, the illustration of the black hole, those illuminating regions here, and the diameter is approximately the distance from our sun to the planet, which is so huge and so enormous beyond my imagination. So that's the massive black hole, and maybe it exists at the center of every single galaxy. And the name of it is a Sagittarius A. So that's that. And as this video has explained, the narrator has explained that we have to depend on the nearby matter, the effects of black holes to others regions, in order to identify the black holes, because they are virtually invisible to the naked eyes. So that's that. We can depend on the acceleration disks, I guess, maybe like the gas and dust forming the black holes, and give it the color like red or yellow, something like that. So yeah, that's that. I need to just clarify some terms here so that you can understand more about the black holes. But black holes are really fascinating, and I definitely encourage you guys to learn more about black holes if you have time. So that's black holes. And then we move on to another concept, which is planet. So what exactly is planet? Our Earth is a planet, right? Mars is also a planet. So a planet is basically a large object that orbits a star. Like our sun, the Earth is orbiting a planet, and it's virtually a planet, right? However, certain criteria will be met in order for an object to be considered a planet. Not everything orbiting a star is considered a planet, right? For example, in 2006, Plato, right? Plato has been eliminated from being a planet, and it has been degraded into being a white dwarf. Why is that? Why scientists have theorized Plato to be a planet and then just regarded it as a white dwarf later on? Well, there's some certain criteria that planet has to satisfied in order to be categorized into the planet regions. Here's some criteria. I did convert this on the internet, but let me just do some quick research. Criteria, which means some requirements that planets have to meet, I guess. Here. So there are three requirements in total. Let me just click on this and scroll down to that point. Okay, so never mind. We're just gonna look at the outside of it. So it says a planet must do three things. First, obviously, it must orbit a star. In our cosmic neighborhood, it is, in this case, the sun. So first, in order to be regarded as a planet, this object must be orbit a star. And then it must be big and huge enough to have enough gravity to force it into spherical shape. So what is spherical shape, you may ask? Spherical shape is the round shape that's like this. Let me just show you a picture because I don't know how to explain this or how to put it into words. So spherical shape. It's like virtually the shape of our planet, like this. It's kind of round, like the globe, I guess. So that's the spherical shape. So it must have gravity in order to be in that shape. And the third requirement or the third criteria in order to meet for a planet to be considered a planet is that it must be also big enough that its gravity cleared away any other objects of a similar size near its orbit around the sun. For example, so the reason why our Earth is considered a planet is because Earth has the power to eliminating every single comet or asteroids entering the atmosphere, right? Because if you notice that Earth has enough gravity to clear away and to prevent the asteroids from entering the planet surface and to cause catastrophic consequences, even extinction. So, for example, 66 million years ago, right? 66 million years ago, the dinosaurs is on the verge of extinction because of a huge asteroid collapse into our planet. At that time, Earth hasn't been considered a planet yet because at that time, Earth didn't have the power or didn't have the authority to eliminate every single asteroids to prevent the worst consequences. But right now, as human beings have evolved and revolutionized, our planet has also evolved and it has created and formulated a invisible, I guess, atmosphere or an invisible layer in order to prevent other objects near it to enter its surface. So that's that. And that's the three criteria that a planet or an object have to satisfy in order to be categorized and to be identified as a planet. So you may come up with this question: why Pluto has been disregarded as a planet? What is the criteria that Pluto didn't meet? Here it is. Let me just do a quick research. Why Pluto isn't considered a planet anymore? Actually, a Pluto, not Plato. I have mispronounced it the whole time. I'm sorry. Anyway, so here it is. It did not meet the three criteria used to define a full-size planet. Essentially, Pluto meets all the criteria except one. It is not cleared neighboring region of other objects. So, what does that mean? That means that Pluto does orbit the sun, right? It does orbit the sun, and it is big enough to gather all the gravity in order to form the spherical shape. However, Pluto does not meet the third and the final criteria of the planet consideration, which is clear away all the objects, the neighboring objects around the planet, around the Pluto. So that's why Pluto is not considered a planet anymore. After some thoughtful consideration, Pluto is officially not considered a planet anymore after the 2006. So that's that. That's about the planet's criteria. So let's move on to another concept, last but not least, which is comets and asteroids. So comets and asteroids are all remnants after planet formation. For example, after the sun's and our solar system's formation, all the remnants or the debris leftovers will eventually created into the comets and asteroids. So yeah, that's just some insignificant information I want to provide with you guys. But basically, comets and asteroids are the leftover of others major planets formation. So that's just an overview of the universe components, which is galaxies, stars, black holes, planets, and the others components such as comets and asteroids. So yeah, that's that. And now let's look more into the solar system. So I'm so sorry because I'm just too lazy. I didn't actually spend enough time, or it's just so time consuming to customize each separate slide for each planet. So I decided to go to the internet and find some resources to read out loud for you guys about our solar system. But don't worry, I will actually explain some complicated concepts along the way to help you gain a better insight and a better understanding about the solar system. Solar system. Okay, so let's see. NASA. It's reliable, right? So here it is. Wait a minute. There's not specific information about each planet. I guess I would have to confer another resources. What about this? What about other resources? Our solar system. Here. Okay, we have this article about solar system. The advertisement's so annoying. Oh, okay. So let's read this. I think it's kind of enough for today's class to learn about the solar system. But yeah, the solar system explained. Our solar system is made up of the sun and all the amazing objects that travel around it. Wait a minute, I have to take a sip of water because I'm so thirsty. Sorry about that. Okay, so let's continue reading. The solar system explained. Our solar system is made up of the sun, obviously, and all the amazing objects that travel around it. So when it comes to solar system, you may instantly think of our sun and the 8 planets revolving around it, but it's not necessarily like that, because our solar system is beyond the planets and the sun or the star. It also includes the beautiful and the fascinating rings of the Jupiter and other components as we've just gone through, such as comets, asteroids, and other debris too. Okay, here it is. The universe is filled with billions of star systems located inside galaxies. These cosmic arrangements are made up of at least one star which is our sun, and all the objects that travel around it, including planets, dwarf planets. In this case, dwarf planets are the Pluto, which I've just explained to you guys, the moons, asteroids, comets, and meteoroids. Okay, so here's the thing. Meteoroids, I forgot to actually explain this for you guys, but you know what? I'm also a little bit confused between meteoroids and asteroids sometimes. So let me just do a quick research about this versus asteroids to see the difference between those two concepts. You know what? I'm just gonna find the first. Oh, here it is. Meteoroids are lumps of rock or iron that orbit the sun, just as planets, asteroids, and comets do. Are extremely common throughout the solar system. Somehow I literally forgot to incorporate this concept into my explanation. Okay, so here's the meteoroids. It's just basically like all those lines that are happening or occurring on our planet, and whenever there's some source of light that passing by the sky, you may have to grant a wish and it will be granted, right? So there's some like myths and this conceptions that whenever meteor is passing our sky, you are allowed to grant a wish, and if you are actually lucky enough, this will actually be fulfilled. So that's this concept to explain the meteoroids as far as I'm concerned. But yeah, that's that. Let's come back to our article. The star systems we're most familiar with, of course, is our own. Home sweet home, which is a very cute term to describe our solar system. If you were to look at a giant picture of space, zoom in on the Milky Way galaxy, and then zoom in again on one of its outer spiral arms, you'll find the solar system. Astronomers believe it formed about 4.5 billion years ago, when a massive interstellar cloud of gas and dust collapsed on itself, giving rise to the star that anchors our solar system, that big ball of warmth known as the sun. Alright, so I did have a video explaining the concept and the process of our solar system's formation, which I will definitely show you guys later, but now let's go over the whole explanation. So, first, the first information about our solar system is that it is formed approximately 4.5 billion years ago, when a massive interstellar, including gas and dust, just collapsed, and then it has formulated and giving rise to the star of our solar system, which is the sun. And then, along with the sun, our cosmic neighborhood includes the eight major planets. The closest to the sun is Mercury, followed by Venus, Earth, and Mars. These are known as terrestrial planets. Terrestrial planets, you may ask what it is, because they're solid and rocky. So apart and in contrast to the wait a minute, we did have another concept about this. Terrestrial and extraterrestrial planets, yes. They're solid and rocky. Beyond the orbit of Mars, you'll find the main asteroid belt, a region of space rocks left over from the formation of the planets. Okay, so it's a little bit complicated, to be honest. Let me just confer another things. Of course, I myself can comprehend the information provided in the article, but because you guys haven't familiarized yourself with the solar system yet, so what I need is a more simplified article that is children friendly. Explained for, oh my god, solar panels explained for dummies. Let's see, for kids I suggest, because the explanation is much simpler and much easier to understand. Let's see this. Why the screen suddenly so dark? Okay. You know what? I have this amazing idea. I'm just gonna do research for each planet alone, for each article, obviously. So first, gonna look more about the Mercury, which is the first and the closest planet to our sun. Here it is. Here, from the surface of Mercury, the sun would appear more than 3 times as large as it does when viewed from Earth, and the sunlight will be as much as 11 times brighter. Because, needless to say, this is the closest planet to the sun, and it has to be the hottest planet, you may ask, right? Because it is the closest, and instinctively, it would definitely be the hottest, but it is further from the truth, because believe it or not, Mercury is not the hottest planet in our solar system, though it has the closest distance between the sun and the Mercury. Why is that? You will figure out later on, as I've explained. But first, the smallest planet in our solar system too, and nearest to the sun, Mercury is only slightly larger than Earth's moon. From the surface of Mercury, the sun would appear more than 3 times as large as it does when viewed from Earth. we've just gone through this like at the beginning of the introduction of Mercury. Let's just skip that repetitive details. Oh, and by the way, here's the models of the Mercury simulated from the computer. So here's the Mars simulation from the 3D models. Well, it looks so cool. So as you can see that here's the first side, it is brighter than the other one. Why is that? I don't know. Maybe it has been hidden from the sun's light and it is literally darker than the other one, I guess. So that's the Mars. It looks so cool, isn't it? And here's some information you definitely need to know about Mercury. First, obviously, Mercury is the smallest planet in our solar system. It is only a little bit larger than our moon. And then, inside track, Mercury is the planet that orbits the closest to the sun. And it also the fattest planet. Mercury is the fattest planet in our solar system, traveling through space at nearly 29 miles, meaning 47 kilometers per second. Oh my god, that's so freaking fast and so incredible. The closer a planet is to the sun, the faster it is to travel. Since Mercury is the fattest planet and has the shortest distance to travel around the sun, it has the shortest year of all the planets in our solar system, just 88 days, meaning over 3. Wait a minute, is that true? Yeah, it's just approximately 3 Earth's months, and 88 days is the whole year that Mercury has. So, Mercury is a rocky planet, meaning that it has a very rough surface, also known as a terrestrial planet, which is a common characteristic that all the terrestrial planets share with each other, meaning that their surface is really rocky and really rough, stuff like that. Next off, Mercury's thin atmosphere, or exosphere, is composed mostly of oxygen, sodium, hydrogen, helium, and potassium. So we cannot live here. You may ask why we cannot harbor life on Mercury, right? Because there's not enough oxygen supplies, and oxygen plays an important role in our survival, right? So it obviously we cannot sustain life on the Mercury surface. And then Mercury also has no moons. Unlike Earth, our Earth has exactly one moon, but Mercury, on the other hand, has absolutely no moons. And there's no rings around Mercury. In fact, I think that all the terrestrial planets, which is Mercury, Venus, Earth, and Mars, has no rings. And here it is. It is unlikely that life as we know it could survive on Mercury due to solar radiation and extreme temperatures. So even though, as I've just stated earlier, that Mercury is not the hottest planet, but it also has extreme temperatures that cannot sustain life. And Big Sun. Standing on Mercury's surface, at its closest approach to the Sun, our star would appear more than 3 times larger than it does on Earth. And NASA has also organized and launched some spaceships to explore further on the Mercury surface, I guess. Here it is. 2 NASA missions have explored Mercury. Marina 10 was the first to fly by Mercury, and Messenger was the first to orbit. ESA's Pepe Colombo, I hope that's the right pronunciation, is on its way to Mercury. So that's about the Mercury. And next up, we got Venus, right? Venus is the second planet from the Sun. Venus. And here's a mind-blowing fact about Venus. Venus is literally the hottest planet in our solar system, even though it is not the closest. Why is that? Because of the amount of carbon dioxide in an atmosphere, leading to the extreme weather of Venus. Because, greenhouse gases will definitely trap heat and leading to the unhospitable planet. For example, our Earth is equipped with a lot of greenhouse gases, and as a result, the temperature is keep raising as a result of climate change, right? So Venus also contains a lot of greenhouse gases because of volcanic eruptions there. So it is really literally unwelcoming for human beings to live and to inhabit on Mercury. So here it is. Venus. Similar in structure and size to Earth. So here's the thing. Venus and Earth is kind of like similar in size, but Venus' thick atmosphere traps heat in a runaway greenhouse effect, making it the hottest planet in our solar system. And here's some information about Venus you can learn more about. I'm just gonna read the first two paragraphs because there's so many planets to explore there. We don't obviously have no time to read each further details, so I'm just gonna read the first two paragraphs. Venus is the second planet from the Sun and is Earth's closest planetary neighbor. It is one of the four inner terrestrial or rocky planets and is often called Earth's twin because it's similar in size and density. They're not identical twins, however. There are radical differences between the two words. Venus has a thick, toxic atmosphere filled with carbon dioxide and is perpetually. Oh, there's a new word for me actually. Let me see. Perpetually means constantly or in a way that never ends or changes. Means like continuously and always in that state. So in that case, it means again with the screen just suddenly darkened like that. Okay, so Venus has a thick toxic atmosphere filled with carbon dioxide and is perpetually shrouded with thick yellowish clouds of sulfuric acid that trap heat, causing a runaway greenhouse effect. It's the hottest planet in our solar system, even though Mercury is closer to the Sun. So a lot of people will be deceived by this information. Whenever I ask my parents or my peers about what do you think is the hottest planet in the solar system, they'll instantly think of Mercury because obviously Mercury is the closest planet to the Sun, but in reality, Venus is actually the hottest planet, so you have to pay extra attention to this in case someone else asks you some trivial questions about planets and you can able to master that. So here, the surface temperature on Venus are about 900 degrees Fahrenheit, which means 475 degrees Celsius, which is really hot and unbearable. Hot enough to melt lead. Their surface is rusty color and is purred, I guess, with intensely crunched mountains and thousands of large volcanoes. Scientists think it's possible some volcanoes are still active, and that's the reason explaining why Venus has so many and a overload of greenhouse gases. It is because of the amount of volcanoes, and even though there are some volcanoes that are still active and still operating. So that's about Venus. And next, we're gonna learn about one of the most captivating, one of the most interesting planet in the solar system, which is Earth. So I guess that you already have a lot of information about Earth, so we're just gonna quickly go through this. So we have some information about Earth. So Earth, our home planet, is the only place we know of so far that's inhabited by living things. This is the only. Wait a minute. Okay, sorry for that because my mom literally interrupt me while I'm talking. So anyway, so Earth, our home planet, is the only place we know of so far that's inhabited by living things. It's also the only planet in our solar system with liquid water on their surface. Okay, so before diving into more information about Earth, I have this weird question. Do you think that Earth is the only planet harboring and sustaining life in this whole vast and infinite universe? What do you guys think? Or do you think that there are some planets out there that has not been identified by scientists yet that actually have some extraterrestrial life? What do you think about this issue? So let me just guess first. I guess that actually Earth, because there's some not enough evidence to suggest that other planets are actually sustaining life. Maybe we haven't identified or determined enough yet, but I think that in the future, as the development of technology and other devices, we can definitely be able to detect more life forms and more surprising facts about our universe. So here it is. Our home planet is the third planet from the Sun, and the only place we know of so far that's inhabited by living things. While Earth is only the fifth largest planet in the solar system, it is the only world in our solar system with liquid water on their surface, just slightly larger than nearby Venus. Earth is the biggest of the four planets closest to the Sun, among, Venus and Mercury and Mars, all of which are made of rock and metal. Earth is the only planet in the solar system whose English name does not come from Greek or Roman mythology. Oh yes, I forgot to actually contain this information in my explanation. That's so frustrating. So basically, Mercury and Venus are all derived from the Greek and Roman gods, stuff like that. But Earth is the exception. Earth is the only exception because Earth is not named after any Greek or Roman gods or mythology. The name was taken from Old English and Germanic a long time ago, so Earth basically means the ground. There are, of course, many names for our planet in the thousands of languages spoken by the people of the third planet from the Sun. For example, English may call Earth as Earth, but other languages will have different names for Earth too, right? Vietnamese will have a different name for Earth, which is Jaidat, and other planets, other languages would also be the same. So that's about Earth. And here are some fun facts about Earth. You can learn more about this. But for the sake of our lesson, I'm just gonna skip this because we don't have enough time. Okay, so I think that's all I want to say about planets because there's so many ways to go, but now the time is really restricted. So I would leave a video for you guys to learn more about the planets. You can watch later on, but for now, I would just go over because we have a lot of more concept to explore. But if we still have enough time at the end of the lesson, I would look more in depth about other planets too. But yeah, that's that. I did have a video for you guys to watch about the solar system, which is also from National Geographic, because when it comes to planet exploration or scientific knowledge, I would definitely think of National Geographic. It is so informative and so engaging that yeah, the videos are definitely amazing. So yeah, I would send you guys this video, but remember to watch it later because we have other concepts to learn. So yeah. I wonder how to actually simulate this video. Wait a minute. Our solar system. National Geographic. Here, this video. I'm gonna send this into the chat box, but remember to watch it later on, because yeah. Anyway, so let's move on to the next concept. Next up, we're gonna learn about the space exploration. There's some recent discoveries that we have just known about the universe, the mysterious universe. We have just discovered some fun facts and some awe-inspiring facts about our universe. So, if you can recall the historical events, exactly in 1969, humankind launched the first manned spaceship, successfully conquered our neighbor, the moon. So Armstrong, widely regarded as the first human ever set foot on moon's surface, has profoundly declared, "There's one small step for men, one giant leap for mankind," which means that the United States is the first nation in the whole world to launch successfully a spaceship to conquer our moon and to further explore and cultivate our knowledge about our neighbor, the moon. And here I have some recent articles about some space exploration. For example, we have flight of the first private spacecraft, we have Hubble Space Telescope, the first satellite in space, first man in space, and the lunar landing, which is one of the most groundbreaking milestone in humankind history of space exploration. So I will specifically learn more about this for you guys today when I look more in depth about this specifically because it is one of the most, you know what I mean, the one of the most innovative invention of humankind to actually send humans to moon and to explore it. I literally have like the video about this exploration literally give me goosebumps when I am doing some research about this class. I did confer some video on YouTube about the landing of our human beings about some decades ago, which is 1969, and it literally give me goosebumps because it shows that how human beings are so innovatively and so desperately attempting to conquer our universe, and there's so more to come too. So yeah, let's learn about this historical milestone events. It is how do we say it? I guess in 1969, the Apollo 11. So again, let's convert to NASA. Oh, there's so much information to digest. Let me see something that is more kids friendly. Oh, here we have National Geographic Kids. So let's read this together. The moon landing, the historical event captivated the world and helped people look to the future. On July 20th, 1969, millions of people gathered around the televisions to watch two US astronauts do something no one had ever done before. Wearing bulky spacesuits and backpacks of oxygen to breathe, Neil Armstrong and Edwin Buzz Aldrin became the first human beings to walk on the moon. After the two stepped onto the lunar surface, Armstrong proclaimed these famous words, as we've just gone through. There's one small step for a man, one giant leap for mankind. So how does all of this exploration originated from? Where did the idea of space exploration suddenly emerged? It all starts from the 1957. So humans were only able to make that small step after several other space firsts happened. In 1975, the first artificial satellite, Sputnik 1, was launched into space by Russia, and that's the first satellite that has been accelerated into the space. And there's this historical event, as my memory serves me right, that the Cold War, when the Soviet Union and the United States are just racing and competing with each other in order to win over and to witness who could ever conquer the planet more effectively. So the United States launched several satellites for their own afterward. Both countries hope to be the first to send a human into space, and this is a very competitive competition and really rigid, it really hurt pouting, stuff like that. It wasn't until 1961 that a person went to space. On April 12th, Russia's Yuri Gagarin became the first. Less than a month later, the United States, Alan Shofad became the first American in space. Okay, so here's some thing I need to clarify first. Yuri Gagarin is the first person to be on space, not to step on the moon. Okay, so that's some clarification. Less than a month after the United States, Alan Shurford became the first American in space, following three milestones. These milestones, President John F. Kennedy issued a challenge to the National Aeronautics and Space Administration, which is NASA, to put a human on the moon in 10 years or less. NASA went to work, obviously. On July 16th, 1969, the spacecraft Apollo 11 prepared to launch a crew of 3 astronauts into space in the history books. Because these historical events have been adapted in numerous historical history books and has been taught in primary, in elementary, in even high schools too. The moon walk. NASA officially selected Neil Armstrong, Buzz Aldrin, and Michael Collins as the astronauts who would make the historical trip from Earth on Apollo 11. So here's the picture of the 3 most widely known men who have stepped on the moon. So here is astronaut Neil Armstrong, and then Michael Collins, and here is Buzz Aldrin. Just 40 after launching from Kennedy Space Center in Florida, the spacecraft neared the moon's surface. And here is oh wow, this looks so cool. The footprint is visible in a shallow moon crater named the Sea of Tranquility. So here's the step of Buzz Aldrin has been engraved into the moon's surface. There's some further information, but yeah, we're just gonna look through this. Oh.
Get ready for it. How about a 3-day road trip?
This video. Oh yeah, I did watch this video before. I'm gonna send you guys this maybe if you want to learn more about the moon and the historical events of Neil Armstrong and the Apollo 11, something like that. So that's that. And recently, in 2002, NASA just launched a recent spaceship again into exploring the moon, which is Armistice, I guess. I forgot the name because it's such a long time. It's like in the November of 2002. So let me just retrieve and recall that. It is Artemis. Yeah, Artemis. And there's some multiple articles about this too. So here it is. Here's a little bit information about the Artemis. The Artemis 1 is the first in a series of increasingly complex missions that will enable human exploration to the moon and Mars that has recently been launched and been liftoff from the NASA spacecraft. Okay, so let me see some resources that we can actually. There's some even Vietnamese articles about Artemis 1 in case you're interested in. Just click on all of those things. But yeah. Let's read this. Space.com. Artemis 1, the first step in returning astronauts to the moon after such a long time. Artemis 1 laid the foundations for future lunar exploration and beyond. So it is noteworthy to remember that Artemis 1 is not the end of that whole mission, because Artemis 1, like NASA also have the intention of releasing Artemis 2 and 3 into Mars someday, maybe in 2024, 2025. So here's a little bit background information. NASA successfully launched Artemis 1 at 1:47 a.m. on November 16th from Launch Complex 39B at NASA's Kennedy Space Center in Florida. And we also have some amazing pictures about this too. It looks so magnificent. And okay, so let's just look at some pictures of that. Pictures. I mean, magnificent photo. Just gonna click on one of these pictures to see. Oh, so as you can see, it looks so beautiful and so, I don't know how to express it. Okay, no word can describe my feelings when looking at this picture. And then we have this one too. 10 greatest images from NASA's Artemis 1 moon mission. So first is some 9 days before liftoff. Liftoff means the official day where the Artemis 1 was launched. NASA's Space Launch System rocket stood in the orange glow of Florida Sunset Launch Complex 39B and NASA's Kennedy Space Center in Florida. And then we have the liftoff. Seconds after ignition, SLS, which is Space Launch System, begins its journey to the moon on November 16th, 2022, and it is lit up the night sky with solid rocket boosters. The ignition of the Space Launch System rocket was so powerful they damaged its mobile launch platform. So here, the ignition is so beautiful, isn't it? The surroundings is just so perfectly combined and blended with the whole image. And then we have the SLS joins the moon in the night sky. And then here's the picture that the spacecraft has captured away from the Earth. And then this picture is Orion breaks distance record and blah blah blah. And then we have this picture captured from the spacecraft from the moon's surface. And yeah, so at exactly on 12:40 on December 11th means that a month from the first launch, Orion splashed down in the Pacific Ocean, some 5.8 miles away from its recovery ship, the U.S. Navy's USS Portland. NASA described Orion's landing as a textbook entry. So here's the picture of the Artemis 1 successfully and accomplished the mission. So yeah, that's that about the Artemis 1. Okay, I guess that's that, and we can definitely learn more about these space exploration events. We have a lot of suggestions here in case you're interested in history and in space exploration. Then check this out. For example, launch of the Hubble Space Telescope. I would send you guys these slides so that you can learn more about this. So yeah, that's the space exploration. And then we have some reflection too. So, the universe is truly fascinating and has captivated our imagination infinitely. We'll surely encounter endless opportunities to further expand our knowledge about the remaining mysteries that have yet to be conclusively answered. There are tons and loads of questions out there that we can possibly come up with to investigate and to further explore our universe. There's some questions that remain a mystery. There's some questions that have not been answered yet, but surely with the rapid development of our technology, of humans' desire to conquer our universe, I believe that in the future, human being will make more progress into space exploration. So yeah, that's the reflection. And thank you so much for joining to the lessons. So I guess that for today's class, I will end the class early so you guys will have time to have lunch, because normally it is around this time that your family would definitely gather some lunch together. So thank you so much for attending today's class, and I will send you guys the slides along with my recording video and the homework for the space exploration. So thank you so much for attending the class. I'll see you in the next week. So yeah, bye, and remember to do the homework because it will be really interesting. So yeah, goodbye. Now I have to prepare lunch for mom because mom is literally screaming for not cooking lunch now. So yeah, I guess goodbye for now, and I'll see you in the next lesson. Bye.